Let's begin with our first problem. A clock shows 3:20. We need to find the angle between the minute hand and the hour hand. Before we start, pause the video and try solving it yourself. To solve this, we will first find the position of the minute hand. The minute hand complete one full revolution or 360 degrees in 60 minutes. So in 1 minute it moves 360 divided by 60, which is 6 degrees. At 20 minutes the minute hand has moved 20 multiplied by 6 equals 120 degrees. So the position of the minute hand is 120 degrees from the 12 o'clock position. Now let's find the position of the hour hand. This is where many students make a common mistake. They assume that the hour hand stays exactly at the number 3, but that is not true. The hour hand moves continuously as time passes. The hour hand completes one full revolution of 360 degrees in 12 hours, which gives 30 degrees in 1 hour. At exactly 3 o'clock, the hour hand is 3 multiplied by 30, which equals 90 degrees from 12 o'clock position. But another 20 minutes have already passed. The hour hand moves 30 degrees in 1 hour or 60 minutes. So in 1 minute it moves 30 divided by 60, which is 0.5 degrees. Therefore in 20 minutes it moves 20 multiplied by 0.5, which equals 10 degrees. So the position of the hour hand at 3:20 is 90 plus 10 equals 100 degrees. Now that we know the position of both hands, we can simply find the angle by taking the difference between them. 120 minus 100 equals 20 degrees. So the required angle is 20 degrees. Now let's express this angle in radians. We already know that 180 degrees equals pi radians. So 1 degree equals pi divided by 180 radians. Therefore 20 degrees equals 20 multiplied by pi divided by 180, which simplifies to pi by 9 radians. The important idea to remember is this: always find the position of each hand first and then take the difference between them. Once you understand this method, you can solve almost any clock angle problem. Now let's move on to our second problem, which is slightly more challenging than the first one. A horse is tied to a post by a rope. As the horse moves, always keeping the rope tight, it traces an arc of 88 meters and subtends an angle of 72 degrees at the center. We need to find the length of the rope. Let the length of the rope be r meters. We know that the angle in radians is given by theta equals L by r, where L is the arc length. In this problem, the given angle is in degrees. So first we convert it into radians. 72 degrees is equal to 72 multiplied by pi over 180, which simplifies to 2 pi by 5 radians. The arc length L is 88 meters. Therefore, the angle 2 pi by 5 radians is equal to 88 by r. Multiplying both sides by r, we get 2 pi r by 5 equals 88. Now multiplying both sides by 5 over 2 pi, we get r equals 220 divided by pi, taking pi as 22 by 7. R, which is the length of our rope, is equal to 70 meters. Now let's move on to our third and final problem, where we will see how geometry and radian measurement work together. An equilateral triangle has a side length of 2 units. A circle is drawn with its center at one vertex of the triangle. The arc of the circle divides the triangle into two regions of equal area. We have to find the radius of the circle. To start the solution, We assume that the required radius is r units. Since the arc divides the triangle into two equal areas, the area of the sector must be equal to the half of the area of the triangle. We know that the area of an equilateral triangle is root 3 by 4 multiplied by the squared of its side. Substituting the side length as 2 units, we get the area of the triangle is root 3 squared units. Therefore, the area of the sector is half of that, which is root 3 by 2 squared units. We know that each interior angle of an equilateral triangle is 60 degrees, which is equal to pi by 3 radians. Next, we use the formula for the area of a sector. 1 by 2 multiplied by r squared multiplied by angle theta, where theta is measured in radians. Substituting the values, we get 1 by 2 multiplied by r squared multiplied by pi by 3 equals root 3 by 2. Multiplying both sides by 2, we get pi r squared by 3 equals root 3. Now multiplying both sides by 3 over pi, we get r squared equals 3 root 3 divided by pi. Taking the positive square root of both sides, we get r, which is the required radius of the circle, is equal to the square root of 3 root 3 divided by pi units. Thanks for watching.